Hello, my name is Natalie Ayers, and I'll be presenting today on my large-scale project, which is an agent-based model on Israeli and Palestinian counterterrorism. This is inspired by a 2012 paper by Laura Dugan and Erica Chenoweth, which examined the effect of Israeli government actions, which they classify as either conciliatory or repressive, and targeted towards terrorists or indiscriminately affecting the entire population, and considering the effect of these actions on Palestinian terrorists and terror attacks. For this reason, I only include Palestinian terrorist agents in the model for simplicity as well, but this is not at all to say that there is only one side that's responsible for the violence in this very complex conflict, and in the future I do hope to expand the model to be more representative of the true state of affairs. For the modeling, I'm using Mesa, which is an open source package for agent-based models. I use this for the additional complexity it allows, especially as I hope to expand this model in the future. However, this does limit my ability to scale out very precisely, particularly because I'm unable to use things like Dask or GPU computing without rewriting the source code, which is something I do hope to do in the future. So for the time being, I was able to use MPI and Lambda functions to scale out my model. As a quick overview of the model components, I have Palestinian agents who have some level of satisfaction with their surroundings and with the actions of the Israeli government, and this satisfaction determines their proclivities towards violence, particularly whether they become combatants. The Israeli government commits one action per turn, conciliatory or oppressive, indiscriminate or targeted, or they don't commit an action, and these actions affect the Palestinians. The actions are determined based on certain parameters that the government holds, including inclination towards repression and their reactivity level towards violence. Every step of the model, the Palestinians react, the combatants have a probability to commit a violent attack and a probability to die from that attack, and the governments choose an action as well. At the end of each step, new Palestinian agents are born. In order to test which models might most closely mirror reality and be able to gain some insights into potential causes of terrorism or mitigating factors, I considered a variety of parameter combinations, including the probability of violence for combatants, the government's policy, conciliatory or oppressive, the reactivity level of the government, the initial discontent of the Palestinian population, which determines how likely they are to become combatants, the starting population for Palestinians, which is measuring overcrowding, and the number of steps in the model. This resulted in over 11,000 different combinations initially, which I ran on Midway using MPI, and only 10 cores, which turned out to be a mistake. After half an hour and 2/3 of my job had completed, Midway cut off the rest of the job, completely understandably, so I looked for ways to reduce the parameter combinations, including by removing models such as this one, which just sees a die-off of the population and doesn't actually mirror reality very closely. So I was able to reduce the combinations of parameters to 5,400, but I wanted to further refine this before I moved back to Midway and MPI. So I tested on Lambda functions next to be able to take advantage of the Lambda instance concurrencies. In order to be able to use my code on Lambda functions, I had to use a Lambda layer, which is a zip file package of all of the packages required for the code. So I used Docker to create this Lambda layer, which I attached to my Lambda functions, along with my actual Mesa model, and each of these Lambda functions takes a single set of parameters. So I used thread pool executor since we aren't able to use Pyren at the moment. Initially tried to use 3,000 concurrent functions, however I realized that our accounts have a limit of only 50, so I adjusted it to only running 1,000 max as a bit of an aspirational setting, and was able to cycle through these 5,400 models. I analyzed these as pandas data frames and narrowed down the model combinations further to 492 promising parameter combinations, which I then moved back to running on Midway using MPI. So these 492 combinations ran on 18 Midway FDR nodes in 51 seconds, and they produced 5 different data frames containing all of the results from all of the models for further analysis. I also produced visualizations for 2 of the models, the one with the highest number of attacks and the one with the highest final population, as I thought they might provide interesting analysis. So the one with the highest number of attacks had a 0.1 initial probability of violence and a mid-level of discontent, and we can see that the number of attacks in orange rises throughout the model, though the number of agents, Palestinians, begins to fall. We can see that the Palestinian status in blue is anti-violence, in red is more sympathetic towards violence. That also increases over time, and this is a geographic representation of the same thing. The highest final population model shows a different story. We see the number of agents continuing to rise, the government performing more indiscriminate conciliatory actions, and the Palestinian status much more positive.